Hello everyone, welcome back to our geometry class. Today we are going to continue talking about central angle and inscribed angle. Today our focus will be doing more practices so we can be familiar with all the features of central angle and inscribed angle, and we know how to use arc measurement to find the measurement of these angles. We are going to look at the two videos. The first video we are going to focus on to practice central angle, and the second one we are going to focus on practicing about inscribed angle. So let's get started. As I mentioned yesterday, no, it's not really yesterday. As we mentioned in the previous class, we talked about the central angle, and we also mentioned the measurement of the central angle is always equal to its intercepted arc. Basically, the end points of the angle on the circle can form a arc. This arc measurement will be same as its central angle. So that's why we use this, or we connect these two measurements together. And now we are going to use this idea to practice the first question. Let's check this question here. So this question we have a central angle here labeled as 82 degree, and we are going to look for ACB, the major arc ACB. Be careful, it's not an angle. It's actually talking about the arc. So first, let's just trace this piece again, so we can easily know this part is one we are going to look for. And also remember, since we know this angle is 82 degrees, so we easily can connect this to its arc. So this piece will be 82. So some students already noticed it seems that this major arc, the arc we are looking for, is actually just the rest piece, the rest part, if we just consider the whole circle. So if we take out this 82-degree arc away from this circle, so the rest part is going to be ACB. So, and also we know the whole circle is 360 degree. So now all we need to do is we use 360 degree to subtract the piece of the arc AB here, which is 82 degree. And then we will get the answer will be 278 degree. And that's it. That's how do we find this major arc, by using the central angle. And also some student might wondering, can I do, for example, since this is 82 degree and the whole circle is 360, so I'm going to use this 82 to subtract from 360, and then I will say, oh, this piece of the arc will match into the central angle in this way. Can I do that? Yes, you are right. It's actually it's perfectly fine using this way. So really it doesn't matter which way you use, as long as you make the connection between the central angle to its intercepted arc, then you will be right. Okay, let's do more practice about the central angle. So in this one, as you can see, we have a circle P. As we mentioned, we use this symbol to indicate this is a circle. And one of the piece arc JK is given at 50 degree. We also know NJ is the diameter of this circle. So now, before we answer these questions here, I always like to label something we know, or write it clear, something I know directly from the given information. For example, I know the JK is 50 degrees, so I know this central angle is going to be 50 degrees, right? Because they are equivalent. And also this little square here, meaning 90 degree, I'm going to label here to remind me. Also diameter NJ. So sometimes some students might say, what's the point we use this diameter? So do not forget. Diameter cut the circle into two equivalent halves. So that means when I look at this half of the circle, I know it's going to be 180 degree. And same thing applies to the bottom half circle. Semicircle is going to be 180 degree. So that's something we definitely gonna, we might gonna use later. So please keep that in mind. Now let's answer the first question. So the first question asking us NHJ arc. So as we can see, it matches to this central angle, so it's very easy to see. It's going to be 90 degree. And for HK, let's check HK. HK is covers from HJ to JK. So it's actually two pieces together. So all we need to do, we just add these two pieces together, and then we will get the final answer, which is 140 degree. And next one is going to be H and K. Let's use a different color to remind us. So H and K, as you can see, is cover the opposite side of HK. It's like the rest piece. If you consider the whole circle is a big pie, we take out the HK, then the rest part is going to be H and K. Again, do not forget, as I mentioned, the orders of the letter does matter, so please make sure you follow the order H, N, K. Do not just go H, K, N, still same letter, but you're actually looking at a different arc, okay? So we follow this, and some student might say, oh, since the whole circle is 360, and I already know this piece is 140 as we just mentioned, right? So how about we just subtract it from 360 and then we will get the answer for H and K. Again, go around the letter like this way so you'll know exactly which piece you are talking about. Now let's work on the last part, which is angle. So this time, as you can see, we are looking at the angle symbol here. So it's going to be MPK. Do not forget the vertex is always in the center. So MPK is actually, some student might say, it seems that I don't know the NK, then how do I know that? But there are actually multiple ways to consider that. One of the way, as I mentioned, NJ is a diameter, right? So as long as I know NJ is diameter, so I know the whole half circle, semicircle here is 180 degree. Since they're next to each other, meaning if I take away 50 from the whole 180 degree here, then we'll figure out this piece of the angle, right? So it's going to be 180 degree because this is actually located in the bottom of the circle, minus 50, then it's going to be 130 degree. Okay, so that's how do we use this information and use a feature between the central arcs and its intercepting arc to figure out the measurement of the arc or the angle. I hope this video is helpful. In the next video, we're going to work on the inscribed angle. Please make sure to check that so you will totally master these topics. Thank you so much for watching this video. Take care, everyone.